In the last two sections, we've talked about taking present value dollars or today's dollars and compounding them into the future. Now let's look at this process in reverse. Now you might ask yourself, why do I care about the present value? Let's say that you know that you need a certain amount sometime in the future. Let's say you're saving for a car. You're going to need $15,000 to buy an economy car 2 years from now. How much do I need to have now in order for it to accumulate into some value needed in the future? Well, that's where we would use the term present value. Present value is the value in today's dollars of some future cash flow or series of cash flows. Discounting is the process of going from future values to present values. It's reversing the effects of time value of money. This process of finding the present value of future cash flow is the process of finding the present value of a future cash flow or a series of future cash flows. The basic equation is the same as we've used before, but now we see that the present value equals the future value divided by this interest rate factor, or this portion of the equation called the interest rate factor. This is where we get the term discounting from, because the interest rate is positive and is positive, so 1 plus a positive number will give us a number larger than 1. This is the relationship between present and future value. The present value will always be less than the future value. So let's take a look at an example. What is the present value of $200 discounted for 1 year at 4% per year? In other words, how much would you have to deposit today into an account that pays 4% per year in order to have $200 1 year from now? We can draw a cash flow diagram just like we have before. So we have a present value, which is unknown, at an interest rate of 4% per year. For 1 year, we need $200. You can see that the down arrow represents the investment or an outflow. The up arrow represents a return or an inflow. We plug these numbers into the present value equation, where $200 is the amount needed, 1 plus the interest rate as a decimal raised to the number of compounding periods. And we find that if we invested or deposited $192.31 today, that it would grow to $200 1 year from now. Let's use the calculator to solve this same problem. So I'm going to first clear time value of money, make sure that my registry is clear. My payments per year are set at 1, so I'm not too concerned about this function at this point, but it will be more important in the future as we start to use that function. Now we enter in the parameters. So we have 1 period, collecting interest at 4% per period. We need $200, and I'm going to leave this positive, or the future value equal to a positive $200. And now we will compute the present value. You can see that the negative sign is there indicating an outflow or a deposit. The solution that I also present here in my notes are related to the interest rate factors that are sometimes used in some texts. In the class, we'll take a look at this current problem.